As a data engineer, your goal should not be just to build the data pipeline. Instead, your goal should be to provide high quality and reliable data to the end user. But here is the problem that I see in the beginners. They pick the tools which are hyped and popular without thinking about the cost, scalability, or the integration in the ecosystem. In this video, I will show you how to think like a real data engineer while choosing the tools. I will also show you how I have chosen the tools and why I have picked that particular tool. I will also show you the different layers of data engineering lifecycle. So before I show you the different layers and tools, let's quickly talk about how to make decision while picking the tools. You need to evaluate each and every tools on the basis of these three things. The first thing is cost and the maintenance. You must know how much it will cost in the long run. Also, is it maintainable in the long run? For example, AWS Redshift is way more better when it comes to the querying, but it is much more expensive as compared to S3. When I have to store the raw data, I will prefer the S3 as compared to the Redshift. The second thing is integration with the ecosystem. So whenever you are picking any kind of tool, make sure that that tool integrates very well with the other tools. For example, if I'm using the S3 for my raw data and for the data warehousing, I'm using the Redshift. So in between, I cannot use the data pro cluster from the GCP to process the data. I should use the Glue or the EMR cluster to process the data because it integrates well in the ecosystem of AWS. The third thing is scalability and the performance. So whenever you are building any kind of data pipeline, you have to keep in mind that data can vary. One time you can process the 100 GBs of data, next time it may be that data increased to 500 GB. So scalability is one of the most important factor in the data pipelines. For example, if I'm using on-premises cluster and it has the capacity to process the 100 GBs of data, but out of nowhere I got the 500 GB of data to process. On that time, my data pipeline will fail or will take a lot of time to process the data. In this point, the cloud technology will help me in processing the data and able to scale the cluster as the demand comes. Now let's go layer by layer of data engineering lifecycle. The first layer is the ingestion layer. It is all about the collecting the data. You identify the different sources of data like the APIs, CSVs, web scraping, or the other data sets. This work is generally done by the data analyst, but sometimes as a data engineer, you have to do the same work. I will be using vanilla Python with the beautiful soup and the playwright. Why? Because it is lightweight and very flexible. It is great in parsing the HTML. Also, when it comes to the error handling, it is also great. The second layer is the staging layer. Once you have identified the sources of data, you will pick the raw data and store somewhere. This storage is called the staging layer. Generally, it will be a data lake where you will be pushing all your raw data. I will be using the AWS S3 for that. Why? Because it is cheap, it is very durable, and for the data lake, it is one of the best choices. Also, it separates the compute from the storage. So when it comes about the scalability, it performs well there as well. The third layer, the most important, the processing layer. So once we have the raw data, now it's time to clean and transform this data. We do the transformation according to the business or according to the end users. I will be using the AWS Glue. Why? Because it will integrate well in my ecosystem. It is serverless and I do not have to worry about the cluster management. AWS will do that for me. The fourth layer, the storage layer. When the data is processed, now it's time to store this data. Generally, the data are stored in the form of facts and dimension in the data warehouses. In our project, we will be storing the data in the Parquet form in the S3. Why? S3 is cheap. Parquet is a columnar format. It compresses well and is optimized for fast querying, either for the analytics. The fifth layer, the serving layer. Now data should be served to the end user. The end user can be the ML engineers or the data scientists, data analysts. For our case, it will be an end user. I will be using the Athena. Why? Because it can query the data directly from S3 with the help of SQL. No need to move data. Plus it integrates perfectly in AWS ecosystem, works well with the Parquet as well. The sixth layer is orchestration and monitoring. To automate and monitor the whole data pipeline, we're gonna use the AWS step function and the CloudWatch. Why? Again, about the integration and the scalability. The seventh and the final, the version control. We're gonna use the Git for the version control. Every code base needs a version control. Why? Because it helps in tracking the changes, collaboration and rollback when needed. Basic but very essential. So this is how a real data engineer thinks, beyond the code and about the cost, performance, and the integration in the ecosystem. From the next video, we will be looking each and every layer of the data engineering lifecycle in practical. Follow Data with Pranjal for more such videos.